Record to this computer. All right. Seeing it as it is 10 o'clock in my world, let's start this event. Welcome and thank you for joining us to this latest TTMAC Child Tech Talk on the future of facades. We appreciate your time. And if you require a certificate for self-reporting CEU, please email me directly and I will get one to you. This Tech Talk is being recorded and will be posted on our YouTube channel for your reference if you need it. There will be time for questions at the end of the presentation. And if you have any questions as we're going along, please feel free to put them in the chat bar and we will go back over them at the end of the presentation. I'd like to introduce Badr. He's been with Ciot for 11 years. He's an expert in large format porcelain and ultra compact materials and has trained hundreds of fabrication shops across North America on the handling and cutting of these materials. With a background in mechanical engineering, he often finds himself sourcing new technologies to integrate into the world of ultra compact surfaces and has been involved in many R&D testing sessions with various manufacturers around the world. Badr is also heavily involved in the industry and sits on the TTMAC board of directors. He's also the chair of the Tech Talk committee and is chairing the new Gauge Porcelain Panel and Tile Manual, which we hope to have ready for you soon. Thank you, Badr, for your time and your knowledge. Now let's get this Tech Talk started.
Thank you, Lisa. I very much appreciate it. And welcome, everybody. Very much appreciate your time. These Tech Talks are very important for the industry, and we try to put them out periodically with information that's related to the industry, new and up-and-coming ideas from various manufacturers and various trades across our magnificent industry. So today we want to talk about the future of ventilated facades. We're going to get into some of the materials that are currently integrated with these ventilated facades, and we're going to talk about what they are and their advantages. And like Lisa said, if you have any questions, please feel free to ask through the chat, and we will address them at the end of the session. Okay, so basically today we're going to talk about ventilated facades, also known as rain screen systems. These are interchangeable terms. We want to give you a quick overview on sintered stones or gauge porcelain panels, which are integratable with these ventilated facades. We want to talk about green building contributions. Then the attachment systems, we're going to look at some case studies and other projects that you might find very fascinating from a design and architectural and engineering perspective. So let's talk about rain screen and or ventilated facade systems. So why ventilated facades? Material selection is very important when it comes to ventilated facades, and you want to look at things like environmental factors. So you want resistance to water, wind, sunlight, and severe weather conditions, kind of depending on the geographic location that you're in. There's also the human factors with inadvertent or intentional damage like graffiti, or somebody's cleaning a sidewalk with a machine and they hit your building and cause some damage. The capability of design when it comes to appearance, aesthetics, and design potential with these facade systems and these materials is almost unlimited. And of course, the lifespan of that facade, you want it to hold up over time. You want it to be virtually maintenance-free. And you want it to be easy to maintain over time in terms of cleaning, durability, and repair if there should be a repair required. From an installation perspective, you want the ability to install, you want cost effectiveness, and you want efficiency. And these are really some of the criteria that are centered around building facades. And of course, with a new product category of sintered stone or gauge porcelain panels, these can be used on these rain screen and ventilated facade systems, siding applications, but they have an unlimited design potential in terms of look, and the ability of the material to hold up over time has been tested throughout the years when it comes to these type of products. The advantages of ventilated facades are quite amazing, actually. So moisture management, we know that moisture on a building is something that needs to be controlled. So a ventilated facade allows an airflow or convection current behind the actual surface of the facade, which allows moisture to dissipate from the building, and it also prevents moisture from getting onto the substructure. Thermal insulation, of course, thermal bridging is a big was a big factor when it comes to facades. So with the continuous insulation, with the addition of this convection current behind the building, you get huge thermal insulation property. So we've all seen glass buildings, very, very hot in the summer. AC is always continuously running, very, very cold in the winter. Heat's always running. So energy efficiency is at a minimum. So with ventilated facades, you can have a 40% increase in energy efficiency. And of course, the enhanced acoustic performance. So these type of systems have a very good way of limiting noise into a building itself. So these are some of the advantages of facades these days. So what is a ventilated facade? So a ventilated facade is a mechanical fastening system that has multiple components. So you have the substructure, where you have an actual railing system that's typically made from aluminum or stainless steel that is attached to the load-bearing areas of the building. This is engineered, of course, in advance, and these things are done through the architects and engineers to find where these load-bearing areas of the building are. You have a thermal insulation, which is embedded into that, and of course, an air cavity between the thermal insulation and the actual skin itself that allows for this convection current we talked about, and the exterior cladding material, which in this case, we're looking at a gauge porcelain panel or sintered stone. One of the things that can be integrated with these facades, of course, and one of the biggest aspects of any building is maintenance. And the maintaining of an exterior facade can be extremely difficult. We see guys on lines, we see cleaning mechanisms, we see structures that are put on top of big high rises that allow for people to come down and clean these facades. Gauge porcelain panels specifically can be coated with a titanium dioxide nanoparticle, which has some really, really amazing effects. So one of the biggest effects is a process known as photocatalysis. So titanium dioxide reacts with ultraviolet sunlight and can actually act as an air scrubber. So from a social perspective and from an environmental perspective, your buildings can become air purifiers. The other thing is a super hydrophilic effect. Hydrophobic, you might be aware of. You've had a car wash, the water hits your car and it beads away and it kind of scurries away from your surface. This is a hydrophobic effect. Super hydrophilic is the exact opposite effect. So the water molecules actually cling together. So in the morning, if you have dew, if you have a rainfall, you actually create a sheet of water, a curtain of water that can come off the building. So for all intents and purposes, the building becomes self-cleaning. It's decontaminating, antibacterial, anti-odor, anti-allergen. So you can, with a topical additive like this titanium dioxide, you can actually make your building virtually maintenance-free from that perspective. I want to give you a quick overview on sintered stone and gauge porcelain panels to give you an understanding of why they have become almost a top choice when it comes to these type of ventilated facades. So the manufacturing process really has a lot to do with this. So just in a nutshell, this is what you can expect to see on a manufacturing of most gauge porcelain panel and sintered stone factories. It's the production of the raw materials. This is a very involved step. This is hundreds of steps involved. It's a manufacturing plant by itself. The minerals are pure. They're pulverized and they're put into a mix based on what's being produced. They're sent into the production line where they're spread onto a conveyor belt. They're pressed at roughly 400 tons. They rectify the edges. They go into a drying chamber. The digital decoration, which if you've dealt with sintered stone panels or gauge porcelain panels, it's the technology has come so far that stone purists are hard pressed to differentiate between a natural stone and a gauge porcelain panel these days. And not to mention that with the digital decoration technology, there is an unlimited array of design capabilities to the point where you can customize a print. If you want to idolize your in-laws on, let's say, the side of your building, you can feel free to do that as well. So and it comes down to quantities, of course, but there are specific patterns of prints that are in the mix. The sintering process, which we're going to kind of talk about, this is where the magic happens. And the sintering process is where really all of the characteristics of these materials come from. And of course, a very, very high quality control process that eliminates a lot of the bad slabs from entering the marketplace. So speaking of sintering, you've heard the term sintered stone, and sintered stone is a a term that's free on the marketplace now. It's synonymous with large format porcelain. And from an ANSI perspective, and like Lisa said, we're working on a new manual for these type of products. And it's recognized by ANSI as gauge porcelain panels or gauge porcelain tiles. So what is the sintering process? So you start off with these powders, these particles that are very porous, a lot of air in between these particles. You compress them down into a semi-solid, almost kind of a chalk consistency, but still very porous under microscopic conditions. And sintering takes place when you take this compound and you heat it to the point just before liquefaction, and you get this atomic diffusion of particles where you are now essentially fusing this mass together into a dense, ultra compact surface, all the characteristics of these sinter stone panels and gauge porcelain panels really come from. This is just an example of one of the designs that you can expect to see from many of these manufacturers that produce these type of panels. So technical features, we say near zero porosity. We're talking about a 0.05, 0.08% absorption rate. We're going to say graffiti proof, resistant to high temperatures. This goes so far as to say thermal shock resistant, huge resistance to bending. We say they're ultra hygienic. Again, because there's no porosity, bacteria really has nowhere to propagate except on the surface, which is very cleanable. I should also mention that because there are no resins used for the binding process in these materials, that they are VOC free. They're lightweight. A 6 mil slab weighs roughly 3 pounds per square foot. A 12 mil slab weighs roughly 6 pounds per square foot. Huge scratch resistance. Again, because there's no resins, huge UV resistance. We have yet to see one of these panels discolor under sunlight or UV conditions. And freeze and thaw proof, which again makes them ideal for an exterior application. For all us environmentally conscious people, and thank God Canada is still one of those countries, there are a lot of environmental implications. The material is 100% composed of natural material. They're 100% recyclable. Some of these factories can even have up to 98% recycled content. And there's no added quartz. Crystalline silica free, which is below 9%. Taken action towards decarbonization. So for instance, this particular factory had a 19% reduction in scope 1, which, as you know, are emissions generated directly by the factory, and a 28% reduction in scope 2, which are indirect emissions through other manufacturers or processes that they use that are not directly related to these factories. So very, very sustainable products from that perspective. You can expect to see these type of certifications on many of the factories that exist out there, from EcoVadis to Declare to Green Guard, you name it, a lot of these certifications are in place. For today's purposes, we want to look at the NFPA 285 and its Florida product approval for these facade systems, which we'll talk about momentarily. Okay, let's get into the actual attachment systems now. So attachment systems are adjustable, okay, usually with aluminum channels and T's. The panels are attached to these channels by various methods. The system is fantastic in that in most cases it can be adjustable, it can be related and adaptable to most substructures. And of course, this is a system that transfers structural loads to the actual building itself. So let's look at some of the attachment systems that we're going to discuss today. So we have something like the strong fix system, a visible mechanical system, a hidden undercut system, a hidden system with a recessed groove, a hidden chemical system, the hidden slim system, and then a hidden chemical system with an additional reinforcement. So these are all different types of facade systems that you can expect to see. Let's start with something like the strong fix. This is kind of, you know, a Cadillac type system that's on the market. Very, very versatile. This type of product here would have Florida product approval for wind loading, wind load ratings. Now, Florida has one of the most stringent wind load requirements in North America for obvious reasons. Hurricane Allen. There's a lot of wind loads that affect buildings in Florida. And one of the ones that is most actually sought after is this Miami date approval, which a lot of these factories and companies are working vigorously to get these approvals. The other one is the NFPA 285, which as you may or might not know, NFPA 285 means that for external facade systems, an NFPA 285 rating means that the system does not propagate fire. So if there's an external fire, an NFPA 285 rated system will be cleared that it will not help propagate a fire on an exterior of a building. If you all remember, some years ago, there was a massive exterior fire on a building in Dubai, where there was a fire that hit the exterior cladding of the building that just went up like a candlestick, like a chimney, and it propagated very, very, very quickly. And this had to do with the chemicals that are used on the facade system. So these systems with these ratings are extremely important, specifically in the North American environment. Now, a system like this uses these longitudinal grooves that are embedded along the length of the slab and uses a J-hook system. Now, all of these systems are going to use these vertical T profiles. You're going to have the dead load brackets that start at the top of the T profile and wind load brackets throughout the length of the T profile that are engineered, and the amount of wind load brackets are going to be based on wind loads in the area at that time. You could have wind loads, you could have an open area, you could be in a downtown core where there's a wind tunnel effect. You could have wind turbulence and eddies from other buildings in the surrounding area that could add wind load. So all this is taken into effect and taken into account when these systems are designed. What's cool about this type of system is that you can use thinner slabs. So this is designed for 6 and 12 millimeter thicknesses. So a lot of times, usually at the podium of the building, you might see an architect or an engineer design a thicker slab because they want a little bit more girth at the podium of the building. But once you get up into altitude, really, you don't need more than a 6 millimeter slab. So the advantage of a system like this is that it allows you, for cost saving, of course, to go down to a thinner material, which does have huge cost saving potential. So this is the strong fix system. You also have now, you can get into some cost savings. You have a visible mechanical system. So this incorporates two things. It uses a construction adhesive along the vertical T profile, and then these visible clips. Now, a lot of people say we don't want to see the clips. It all really comes down to some value engineering. But the factories that have these systems actually have a very cool way of powder coating or painting these clips to match the slabs that are being used almost identically. So this is a feature that can be, a lot of them can be blacked out depending on what the architect and the designers are looking for. Realistically speaking, at altitude, once you get up above a certain height, you really don't see these clips anyway. So it's another way of cost cutting that allows a designer or architect an option. Now, at certain altitudes, you might want to go with a system like the Strong Fix again because of its ability to be adjusted and the configurations that are going to be allowed with it. A hidden chemical system it's kind of one off from this. You're taking away the visible clips, and it's just a construction adhesive. The disadvantage of this type of system is that once you place the panel on there and you've got the construction adhesive on, then it's done. So you'll actually see in here a double-sided tape that's used to hold the panels in place until the adhesive cures. Now, what are some of the differentials here? Once this panel goes in, the only way to remove it is to break the panel. With a system like this, you can actually remove these panels individually without having to break any of the pieces around. And this can be remade at factory level, brought in and installed just as simply as the rest of the facade was installed. Then there's something like, for interior applications mostly, you have a cladding system that essentially replaces thin set. A system like this, though, is designed for 6 millimeter panel thickness. The only difference with this is that the wall has to be extremely plumb. So it is just a mechanical alternative to thin set when you're on an interior wall. It's not necessarily a ventilated facade by the very definition of what they are, but it's just an additional mechanical system that could be incorporated into your design should you need it. We have a hidden chemical system with an added clip. So there's multiple different ways that you can use these systems. And again, depending on the height of the building, you might use this on a residential facade, for example. You can have a hidden system with a recessed groove, as you see here. So they curve the slabs on the inside and they're placed onto these different horizontal grids here where they fit into the groove. Now you will see the metal again at height, you don't really see it. And these metal panels, these metal brackets can be powder coated to any color, really to match the slab so you can make it disappear as much as possible. The hidden undercut system, this one you might all be familiar with. It's the keel screw system, and I mean it's a popular system. It's a very strong system. The only disadvantage to this system over other systems is that with the keel screw you need a minimum 12 millimeter thickness, 12 or 20 millimeters, in order for you to get the proper depth that's required for the keel screw to hold for it to be still structurally sound. So a system that's popular, but again, not as cost effective from a material perspective because you need a minimum 12 millimeter thickness. So 6 mil would be not ideal for this type of project. Keel screw, as you know, they drill into the slab and the keel screw goes in and it opens up at the back. So it anchors from the inside out. One of the questions that we might see is that people are going to ask, what are some of the distances that we can get with these mechanical systems? So the windmill brackets start at about 1.5 inches. So if you were to factor in from the sheathing out, you're looking at a minimum of 4 inches from the sheathing to the front of the facade, all the way up to almost 7.5 inches from the sheathing to the front of the facade. So the systems can be designed. And again, with the work of these different manufacturing companies, you can engineer things based on your desires and your needs. So if you need to go further than 7.5 inches, which is rarely required, but if you need to, that can be engineered in accordance with the engineers of the manufacturing company, of the railing company, and the guys that will manufacture the actual systems themselves. But generally speaking, you're looking anywhere from just under 4 inches from sheathing to skin, all the way up to almost 7.5 inches from sheathing to skin. One of the biggest things here is thermal bridging, and of course, you know, thermal bridging is any contact with the substructure from the outside can allow heat loss or heat transfer into the building or heat transfer out of the building. So to avoid this type of issue, all these brackets have thermal isolators to break any thermal bridging. And that's, of course, done on a case-by-case basis. But generally speaking, most of these systems will use these thermal isolators to break or block that thermal bridge from taking place. So this is very, very important because this is a lot of the heat loss or energy wastage on these facades will come from thermal bridging. Let's look at a couple of case studies to get into really show you what the capability of these different systems are and some of the large projects that have been completed across North America. So we all know the Golden State Warriors. This is one that was done with the strong fix system, let's say a system similar, where this entire area down here was done with a mechanical fastening system, a ventilated facade. Now, again, they chose this system for ease of installation and for the ability to be able to replace panels should they need to over time. I will say that the quantities are kind of huge here, and depending on the manufacturer that you're dealing with, this was a custom color that was done. The quantities were large enough, and generally speaking, if you've dealt with any of these factories, the minimum that they want is 40,000 square feet for any custom color. So if you have a facade, you know, a lot of these buildings will exceed 40,000 square feet when it comes to exterior facades. So there's a lot of room, depending on the factory you're dealing with, to customize colors as you need them. So this is an example. There's all the way up this massive wall here and all the way around the actual building itself. This is a Nordstrom in Ottawa. This was a 15,000 square foot installation. Again, every one of these panels, it's got a custom size, custom cut, and the architects and the designers put together this grid that they wanted. And they worked in conjunction with the engineers of the mechanical fastening system to make it come to life. As you see here, you can put lights behind it. I've seen customers that have they want to embed lighting structures onto the railing. They want to run wires. So whatever the needs of the building are, and what are the needs of the insulation requirements are going to be, they will work around that. And you can very easily work within these cavities of a facade system to incorporate a lot of these features that a building might require on the exterior. This was an exterior as well as an interior installation. And you can see here that a lot of areas they embedded lighting into the actual facade for specific effects. You can stagger the depth of these pieces to get a 3D effect if you want. You can do curves. There's really an unlimited array of design, depending, within limitations, of course. You can take a designer's dream and you can make it almost come true with these type of facade systems because they're very, very versatile from that perspective. And of course, we're talking about, the use of gauge porcelain panels that gives the facade a long lifespan with a virtually maintenance-free facade. This is the La Quinta, and if you look carefully here, you will see that this actually incorporates the visible mechanical system. So this wasn't a very high, this is just a couple of stories up on the facade of this particular hotel. But for cost-saving measures, they opted to go with the visible mechanical, and you can see that the brackets have been painted and powder coated in the color of the actual facade itself. So it's visible, but not really that visible. And that really, again, comes down to aesthetics and cost. Budget, of course, plays a big role in these type of decisions. So there's an external flow. You really can't tell from a distance. You really can't see these mechanical clips. There's another building here. This is in New York on Broome Street. I actually know where this building is. This entire area here was all done ventilated facade. These returns were done with a ventilated facade. You can do soffits, you can do inside windows. All of this can be engineered with whoever your facade designer is to accommodate the look and the feel of the building so that the design intent. The thing about these factories is, and these mechanical systems, that there's a design intent behind every architectural drawing, every interior designer, all these have a design intent that they will try ultimately to maintain that design intent. And you know what? It's a collaborative process because they might come back and say, your panel size is going to yield 40% waste. We can do it, but it's going to cost you a lot. If you move to this size panel or these size pieces and these dimensions, we will yield 5% waste. So back and forth, you find a sweet spot, and of course the building comes to life with the effect that you see. So there's a little bit more of a close-up. And the returns can be done multiple different ways. They can be done with miters, which is very rare in this case, or they just butt join them. But again, a little bit of a close-up to give you an idea of some of the features and some of the intricacies behind these designs. That's another zoomed out view of the same building there. Other projects kind of from around the world, but North America as well. Residential applications have become very, very popular for these type of facades as well. Again, easy to clean, easy to maintain, especially with these titanium dioxide additives. You're giving a customer a system and a facade that is going to last them forever and a day, really. I mean, these slabs they're just that durable that they're going to last well beyond the lifespan of the building. And again, easy to maintain. You want to pressure wash it. You want to throw some water on it. But again, with a titanium dioxide cover, the building is essentially maintenance-free by itself. But you can see there's different profiles here underneath, on top. This is all ventilated facade systems. Another example of a large building that was done. This is a hospital. This wall was done in a ventilated facade. The exterior of the building was done in a ventilated facade. So there are really, I mean, I don't have a picture of it here, but there's one of a facade that was done in South Korea that It's got rounded curves and it's got crazy profiles all over the place. But again, designed specifically to be around the windows. You can go into the windows. And this is all something, again, that's done at an engineering level. People will put grills into these facades to allow for mechanical for ventilation systems. So anything can be adapted with this type of system. Another residential application, and it looks, I mean, it looks gorgeous. And there is an unlimited array of designs that can be made available to the designers and the architects. Here's an example where they were able to use a mechanical system here. They did, I think this was only a 4-inch return. They did the roof on the top here, all done in cladding systems. This is an example of what can be done in collaboration with engineers and architects and designers of these particular systems. Okay, so just to kind of wrap up, we'll go into a Q&A session very shortly. So again, with the use of sintered stone and gauge porcelain panels, exterior cladding, it has become a top choice for a lot of architects and designers when it comes to the design of buildings. Unlimited colors and textures. It's a cladding system that's extremely light in comparison to the alternative when it comes to precast options. Economy and durability in terms of it's a long-term investment, and of course the life cycle of the material is unmatched. The ease of installation and I say ease of installation, the professionals out there that install these systems are well in tune with how to install them, and it requires way less labor from an installation perspective than, let's say, a precast job. And of course, the technical features of these systems and the materials that are used with them are unmatched, really, when it comes to any other products on the market. Do we have any questions about anything that we saw today? You can unmute your mics.
Hello, I might have one question.
Yes.
I'm not sure. Have you talked about the budget price?
Yes.
What is the range of
budget pricing is very hard. It's really hard to give a budget price because it depends on the thickness of the material. It depends on the scope of the project, which system you're going to use. So these systems are case by case. You know, I'll give you an example. If we did a quote on a job, it was roughly 8,000 square feet, and I think the system price was in the range of 350, 400,000, because it was the Cadillac system, I call it. It was a high-end system, and they used a 12 mil material. So it all really depends on, and again, it was that price because there was a lot of intricacies involved with the design. So to give a budget price is a little bit tough because it really is case by case. So throwing a budget out there really does nothing for a monetary kind of evaluation. It really is case by case.
Okay, thank you. Also, it looks like the assembly of the system are made prior to shipping on site.
Yeah, that's actually a great question, and thank you for asking that. So these are turnkey systems, and generally speaking, if you go to a factory that has a cladding system and they have the material, it'll be designed, engineered in coordination with whoever's involved on the project, and everything is then cut, grooved, and ready to go on site. So the system comes like a big jigsaw puzzle. Everything is numbered, everything is identified, all the rails come, all the vertical profiles, the horizontal profiles. If the slabs are going to be adhered to the grooving system, it's done at factory, so it comes on site ready to install. And of course, depending on the requirements of the purchaser or the designer or the architect, a certain waste factor is involved. So emergency pieces are sent, or panels are sent that can be grooved with the dish. So it all depends on what's requested. But to answer your question, yes, the system comes ready to install from the factory. It's plug and play at that point for any installation professionals who install these type of systems. Thank you. That's a great question.
Okay, thank you. And do you know that when you say grooving, you mean
so I'll give you an
what is
example.
on the back of the ceramic tile?
let's just go back to
Is it done in with the CNC
close
routing
your eyes.
machine?
If this is giving you vertigo, I apologize. My computer's gone. So if I give you an example here on the strong fix system, so these 45-degree grooves with
Yep.
this with these type of panels here. You see this? You got the hook. So this would be done at the factory. This would come glued onto these panels at the factory, and the number of horizontal profiles installed on a panel will be dependent on the number of wind load brackets that are required. But something like this would be done at the factory. So when you come, you literally pick up the panel and put it onto the horizontal profile, to the J profile, once it's installed. A system like this, again, yeah. So if you have to install these, with a system like this, of course, there's nothing that's going to be attached to the actual slab itself, because you're incorporating the mechanical fasteners or these clips into the actual installation itself. So anywhere where there is going to be anything required to be attached to the slab is done at factory level. I will say this, and I should have mentioned this earlier, that all the slabs for all, so something like this, for instance, this would be grooved at the factory. Okay, would come ready to be installed from the factory. And all of the panels are going to be meshed at the back, and this is done for code reasons, that if, heaven forbid, there's ever an impact to the building, and the slab fractures, that the mesh holds it in place and keeps it from shrapneling and splintering out, and raining over anybody that's downstairs. So there is also mesh by requirement on the back of all these slabs. So I hope that answers your question when I meant grooving, and any mechanical parts that have to be attached to the slab are done so at the factory, and the slab panels themselves will come cut to size from the factory.
Okay, thank you.
Okay, do we have any other questions, Lisa, on the chat?
Not that I've seen, but anyone's welcome to ask any now. Unmute yourself and ask away.
Yeah, go ahead. Throw them at me.
I would be interested to have the presentation if you can share.
Yeah, I believe this is recorded, Lisa, and it will be shared with through the TTMAC channels, of course.
Okay,
Also,
great. Thank you.
individual PK sessions can be arranged as well. Just reach out. We'd be happy to accommodate you from that perspective as well. Who are you with? Sorry, if I don't mind asking.
My name is Jerome from Ceratec.
From Ceratec, how you doing, Jerome? Nice to meet you.
Nice to meet you.
Do we have any other questions?
Hey, Badr, it's Dale.
Hey, Dale.
Hey, how you guys doing?
Good, brother. What's going on?
It's a good presentation. I really liked it. Very clean and straight to the point. Just a question on the recycled content. How much
Yeah.
are they getting into post-consumer versus pre-consumer? Do you have any idea? Are they getting higher up? Because I think it's mostly pre-consumer that they're using for
They're working on getting higher up, but I'm going to tell you one of the and Dale's one of our experts, by the way. Dale Kempster has been part of TTMAC forever and a day, and he's one of the guys that's I call him Data. If anybody remembers Star Trek, he's got so much information and stuff. But Dale's one of our experts on this life cycle analysis that are happening. And one of the things, if you look at EPDs and HPDs that are being put out, they are looking at more post-consumer recyclables. These are numbers that are going to be coming out of the factories. But they are trying to increase that number, like you say. But I don't know what that number is just yet, to be honest with you.
Yeah, it'd just be interesting because I know that it's something that the architectural community is looking for, and obviously pre-consumer is still better than nothing, but the post-consumer is what really creates quite a bit of value.
Yeah, well, I mean, so a lot of factories that we deal with specifically now have, you've heard of cradle to grave. We talked about this cradle to gate. They have cradle to cradle life cycle certifications now. So we are looking more at this post-consumer recyclable content and information that I think is going to be coming out of these factories. But a lot of these factories now, the very nature of the production of these materials makes them sustainable. But now it's about telling the story and
Right.
the environmental story, the more the more these materials are, the more they're accepted by, and more we're starting to see architectural firms and design firms demand HPDs and EPDs from these factories before they even consider specifying these products. So the more information that these factories put out from that sustainable perspective, the better it is overall, and it's going to lend assistance for more and more people to want to specify these types of products. They really are very sustainable from that perspective. They're natural minerals, and much better than the alternative, the VOC-free aspect, the ability to incorporate titanium dioxide. The green story is massive, and they will just continue to add to that with information like more post-consumer recycled information.
Yeah, what's happening now is that before all they wanted to know is if you had an HPD or an EPD, but now because most people are investing in getting it done, now they're actually dialing in and looking and saying, okay, well, what is their recycled content pre-consumer, post-consumer, and making comparisons and making those decisions off of the numbers now rather than just that you had an EPD or an HPD.
Yeah, agreed. The factories are very cognizant of these conversations that are happening, and they're not happening everywhere. I mean, if you go to the US, it's not so prevalent. I mean, it depends on what state you're in. In Canada, it's very prevalent. In Europe, it's very prevalent. So the factories are hearing these things, and they're the HPDs used to be EPDs, and just so that we're all talking, in the EPD, if you guys don't know, is the Environmental Protection Declaration, and the HPD is the Health Protection Declaration that has more of a human and social impact to what the factory does. So before it was an EPD was good enough, and now they want the EPD and the HPD, and now they want specific content from the EPD and the HPD. So this information is going to become more and more fluid as these progress, because the world of gauge porcelain panels is fledgling. It's still a baby, and the technologies are increasing year over year, and the information is just going to become more and more prevalent for the public to kind of consume from that perspective. That's a good point, Dale. Thank you.
Yep.
Do we have any other questions or comments? Anything that you wanted to know?
They are building a few of these factories now in well, I guess mostly just in the United States for North America. I guess near Crossville, where they get most of the raw materials. Correct?
Say that one more time. Sorry, Dale, I lost you there.
I said there's now starting to build some of these factories that can make the gauge porcelain slabs and panels in the United States now. I guess probably never be in Canada because we don't have the raw materials. But I think there's now 3 or 4 of them now that are either there or planning to build there.
Yeah, so the raw materials is really one of the biggest stories here, and it depends on one of the main sources for these type of materials is kaolin clay, and it's a very purified form of white clay that traditionally came from the Ukraine, and once the war started, of course, that companies had stockpiles. Neolith had what they called the White Mountain, and Iris had the White Mountain, and they all boasted about how much material they had. Nobody thought the war would go this long, and of course their stockpiles ran out, and they had to find alternative sources for these materials. So the main ingredients would be kaolin clay, feldspar, and frit, which is just a purified form of glass. And they take all these components, combine them together by volume, by weight, etc., based on the current compound formulation that they need. But these minerals became almost in short supply, and they had to find alternative minerals to this kaolin clay from other sources. And in fact, at one point, and the industry knows this, there was a situation that happened where a lot of the slabs that started coming in from the factories had tension issues. And that's because they had to basically reformulate with different types of clays of different composition, and they had to retweak their systems. That's since been corrected, but there was a period of time there where we saw slabs tension issues that popped up that we hadn't seen from since the beginning of porcelain slabs. So yes, they're producing in the United States. A lot of them are going to be importing a lot of these minerals from overseas, believe it or not. But more and more, they're looking for alternative sources, specifically local sources and local mineral sources that they can incorporate into the production of these slabs. Yeah, that's a good point too.
And they've seemed to have solved it then, because I know I had a
Yes, they did solve it. For sure. They didn't take them very long, but they were able to solve it. Listen, this is part of the pivot that has to happen based on, I mean, natural resources are natural resources. They're not infinite, they're limited. And eventually it
right.
gets to the point where you have to find alternates and kind of reformulate and rework what you were doing with resources that was abundantly available. That's all of a sudden been removed from the marketplace.
Oh, it's good to know because we've had some failures in Europe, and we were actually supposed to have a technical discussion about it and see where you guys are at with it. So it's good to know.
Yeah. Any other questions or comments on anything we saw today?
Badr, hi, Shamana here. Hope
Shamana,
you're
how
doing
you
well.
doing, sir?
Good. How are you? How are you guys? Hi, Lisa. How are you? Badr, can you just talk a bit more on that NFP 285 rating? Anything that you can share?
Yeah, listen, it's a known rating in the world of facades, and if you know a lot of engineers and architects who deal in this world will understand an NFPA 285 rating basically is it's one of the highest fire protection ratings that an exterior facade system can have. And the designation comes, and not all the mechanical systems are going to have these designations. So you have to check with the individual manufacturers of these systems whether or not they have Florida product approvals, NFPA 285, and if it's not NFPA 285, what fire rating system do they have? The NFPA 285 does not refer to any individual portion of the system. It refers to the system as assembled in its entirety. Okay, so for instance, the gauge porcelain panel slabs, for the most part, have what's called a Class A fire rating. They don't burn, they don't release emissions. There's no toxic emissions if there's a fire. And they don't allow the propagation of fire as individual entities as slabs. The NFPA 285 gauges the entire system. If you have chemical adhesion, if you have mechanical fastening, if you have sheathing in the building, fire retardant material that's on the inside or insulation, and the skin itself. So the NFP 285 evaluates the system in its entirety with all of its components. So this is very important in the world of exterior cladding.
Now, this testing or this results for this test is provided by the systems manufacturer or the cladding?
So the systems manufacturer, if they have the NFPA 285 rating, will have conducted through third party, of course, through laboratories. They will have paid for the necessary testing in order to get the certification. Just like any certification, you're sending it to a laboratory. They're taking your system, they're putting it through the ringer, and they're testing it according to their test standards in order to get that rating.
Okay. It's not project specific, correct?
It is not project specific, it is system specific.
Okay. Thanks, Badr. That's great.
No problem.
Great presentation.
Thank you, sir. Any other questions? Okay, we're just about at time anyways.
Yeah.
I want to thank everybody. If you do have any questions that you think of after the fact, please reach out to Lisa at the TTMAC. Just go to our website and send us a question. Look out for our next Tech Talk. We're always engaging the community for topics that you might want to hear about. So if there's something specific that's been burning your brain and you really want to know about it, please let us know. We have the ability to source all kinds of speakers. You know, our friend Shamana, who just spoke at a master class in Winnipeg last year at the convention with a tech talk on sustainability, and we had another one of our directors, John Alley, do another master. So we have access, and if you yourself have information that you would like to present to the community, we'd love to have you on as a guest speaker with our tech talks. So look out for the next topic. We're going to set out some new dates and put it out to everybody. And we thank you very much for your time and look forward to seeing you at the next one. Oh, by the way, the Toronto Social Night is at the Woodbine Racetrack this year, November 27th, right, Lisa?
I'm on a conference call.
So look out for your tickets. It's going to be a fun event, and we look forward to seeing everybody there. Thank you all for joining, and we'll talk to you soon. Enjoy the rest of your day.
Thanks, Badr.
Thank you.
Thanks, Badr. It was good. Very
All right,
good.
guys.